Okay, to get started, what I want you to do is I want you to think of your top 3 famous scientists. And we'll pause the video now for a second, and we'll talk about it in just a minute. Okay, so obviously I made this video before class, so I Googled most famous scientists, and I came up with this list. So who was on this list that you guys came up with? I imagine Albert Einstein, maybe Isaac Newton, maybe Galileo. Who knows? Maybe some of you who are into astronomy, Stephen Hawking, or maybe even Neil deGrasse Tyson, because he was on Cosmos now. But anyway, so let's talk about a few of these. I've got about 7 or 8 tabs open, and I want to talk about these one by one. So I Googled Einstein and I Googled math, and so this is what I came up with. Einstein did his experiments in his head. He did thought experiments. He would think about things, and then he would go to a chalkboard and he would be like, okay, does this work? And so, yeah, Einstein did a lot of math, and I don't think that really surprises anybody. The next thing I did was I typed in Isaac Newton and math. And I don't know if you guys knew this, but Isaac Newton actually invented a kind of math called calculus. He invented it because he needed it to solve problems that he was interested in. So Isaac Newton came up with all sorts of stuff that we use today. Like if you want to launch a rocket into space or to the moon or wherever, we use his equations. If you want to figure out what kind of force it takes to accelerate an object, we use his equations. So Isaac Newton did lots of math. What happens if we go back a couple thousand years to this guy, Archimedes? 2,000 years ago. They weren't doing math then, right? They were all dumb people, weren't they? No, that's not true. A couple thousand years ago, Archimedes and his pals, they would think about math and look at some of the stuff that they figured out. They figured out that the biggest flat surface inside of a sphere is 4 times smaller than the overall surface of the sphere. So that allows us to have a nice easy equation to relate those two. They thought about how big cylinders were. They got the equations for that. What else? The radius and little sections of a circle. They figured out how to solve for those. Look at these relationships here. Here's part of a circle. Here's an angle. They figured out that O times B divided by over A equals C times B over A times C. Just stuff like that just kind of blows my mind that 2,000 years ago they could figure these things out. So yeah, they were doing math a long time ago. So now what we just covered was some famous examples, but what about this? What about biology? Do you think they do any math in biology? You know, in biology you're thinking what, like cells and like little amoebas and blood and trees and stuff like that. Well, what I did was I typed into Google, I typed in biology and math, and I got one of my results was this study. And this study says body size and temperature, why they matter. So scientists went out and they measured how big these creatures' bodies were, and then they measured their temperature, and they looked for relationships. And what did they find? They found out that there was actually a mathematical relationship between the two. So when they put them on a graph, right here it's heat produced per day and their body weight in kilograms, they figured out that creatures fell somewhere on this line. So these little tiny creatures that didn't have a big body weight made this much heat in a day, and big creatures like an elephant made this much heat in a day. So what you could do with this was you could predict what other creatures would, how much heat they would predict in a day. And then you could go out and you could see if you were right. So there's an example of using math in biology. Or how about evolution? We want to know how fast creatures change over time. Well, what we do is we look at genes and we see how fast genes change. And so we can make a graph of generations versus changes in DNA, and we can figure out, oh, this is how long this has been going on. So there's math in all this stuff. So far what I've covered then is the famous examples, math and biology. What about this? What about what my bosses tell me? In other words, to keep my job, what am I supposed to teach? Well, I want to start with physical sciences, physics and chemistry. So I'm going to start with chemistry here. And this is the website for the state of Michigan, the high school content expectations for chemistry. And what I did was I did a search for the word calculate. So let's see here. The word calculate comes up. Let's see, calculate the pH, calculate delta H, that's the heat change, calculate the delta H again, calculate the amount of heat produced, calculated from, okay, this is E equals mc squared, so using that. Let's see, calculated from percent composition, so we're doing percents in chemistry. I guess that's not a surprise. Percent by body weight, or percent by weight. So that comes up over and over again. Let's look at physics. In physics, the physics expectations, this is from the state of Michigan again. In physics, I also did that search for the word calculate. Calculate changes in kinetic and potential energy. Calculate impact speed. You know, if you drop something, how fast is it going to hit the ground? Calculate the amount of energy. I think you get the point that over and over again, you have to use math in science. Now, I'm not going to say that you have to use math in all science, but I'm saying that in science, that it's kind of a language. It's kind of like the way that I think of it is like this: that math is the main language. Oops. Of science. So you can't really speak science unless you can speak a little bit of math too. So what about the future? The future is, let's see here. This is a website called nextgenscience.org. This is what we're moving toward teaching in science. So just for giggles, I looked up the physical science benchmarks because, you know, this is physical science class, and I looked for the word math. So let's just see. And every time math comes up, they highlight it in this little purple here. So let's just scroll down and see how often the word math shows up in the science standards. And sometimes you see there's none, and then it shows up. There's a couple, there's a couple, there weren't any in that one, none in that one, and then there it is again. So every so often in science, you see that math shows up. As you keep going, it looks like there weren't any for a while, and then there's a couple, there's a couple. So yeah, there is math in science, and that's what I'm supposed to teach you guys. So by now, you might be wondering, what in the heck is he doing? Why did he make this video? Well, who did I make this video for? I made this video for someone. Or actually, maybe a couple of someones. Usually, in any class, there's one or two kids that ask this question. Why do math in science class? And before they ask me that question, I like to show this video so that way they have a more informed opinion. That way they're not just coming from a place of frustration like, hey, he's asking us to do math and this isn't my math class. I get it. I understand that, you know, you can get frustrated. People have studied, you know, frustration and anger. There's a cycle that you go through. You know, you get angry, you feel resentful. You go through all these stages when you're thinking about that kind of stuff. But if you think about it like this, math is a language that we use to speak science, then you can realize, oh, okay, this is a tool to help me learn more stuff. And I hope that helps.